So last lesson we did our 2D surds, but we did questions 1, 2 and 3. Now they're going to get a bit more complex as we go on to questions 4, 5 and 6. So I'm going to do as an example question 4B. So 4B says express each of the following with rational denominators. So the equation is 1 on root 7. A rational denominator means it doesn't want a surd on the bottom. So what I'm going to do is multiply by root 7 over root 7. If I do that, I'll get root 7 on the top, and on the bottom I've got square root of 49, which we know is 7. So now you can see I've got a rational denominator. It's not a surd, and sometimes the technique is called rationalising the denominator. What about if we look at h? In 4h, it's 1 over 2 minus root 3. So you might remember from earlier year levels when we talk about the difference of perfect squares. Difference. And the acronym we remembered that by was DOPS, difference of perfect squares. So when we do it, we might have something like we use a squared minus b squared equals a minus b, a plus b. So the difference, subtract perfect squares, a squared and b squared. This case we've got surds, but it's the same principle. Let's look what happens. If I multiply this by 2 plus root 3 over 2 plus root 3, which we call its conjugate, so you can see that sign has changed to a plus, and this becomes a difference of perfect squares like this. So as I expand out, on the top I'll have 2 plus root 3. On the bottom when we expand it, we're going to have 4 plus 2 root 3. Minus 2 root 3, and then we'll have minus square root 9, which we know is 3. So we'll end up with 2 plus square root 3. These will cancel out, and we've got 4 minus 3, which is 1. So the answer is just 2 plus the square root of 3. So let's go on to question 5 and see what we're going to do there. I'm going to do an example. I'll choose 5B, and it says root 5 plus 2 squared. So let's write it out. Square root 5 times square root 5 is square root 25, plus 2 root 5, plus 2 root 5, plus 4. So this is 5. 5 plus 4 is 9, plus 4, square root 5. What about one like? The next one I'll go through is 5f. And 5f is root 3 plus 2 over 2 root 3 minus 1. So what I'm going to do is multiply that by its conjugate, 2 root 3 plus 1. Over 2 root 3 plus 1. So effectively I'm multiplying by 1. But if I make these opposite sides, we'll get a difference of perfect squares and it will cancel out. So let's have a look what happens on the top line. 2 root 9 plus root 3 plus 4 root 3 plus 2. On the bottom we'll have 4 root 9 plus 2 root 3 minus 2 root 3 minus 1. So let's tidy this up. 2 times square root 9, that's the same as 2 times 3, which is 6. So 6 plus 2 is 8, plus 5 root 3. On the bottom, 4 root 9 is the same as 4 times 3, which is 12. So we've got 12 minus 1, which is 11. And then 2 root 3, take 2 root 3, is cancels each other out. So we can see we get a rational denominator. And the question actually says express in the form a plus b root c. So what that means is I'm going to write this as 8 on 11 plus 5 root 3 on 11. So my value of a is 8 on 11 and my value of b is 5 on 11. So you can go ahead now and finish off question 2D, where you've got parts of 4, 5 and 6. Just use your work completion sheet.